Hey everyone, let's do the practice problems for Unit 7.2, Lesson 8. So the warm-up is asking you to identify which of these graphs represents a proportional relationship. And so in today's lesson, you should have talked about the fact that proportional relationships, their graphs always have two very distinct characteristics. And if you see these two characteristics, then you know it's the graph of a proportional relationship. And if you don't see both of these characteristics, then it's for sure not the graph of a proportional relationship. So I'll write these over here in this sort of like blank space I have. Characteristic one is that it has to make a straight line. It can't be curved or have any like jagged edges in it or steps or anything like that. It should just be a straight line. And then the second one is it must contain the origin. The origin is the point 0, 0. And so we can quickly talk about why those things are, and then we'll move on. So the graph of a proportional relationship always creates a straight line because the two quantities involved here, the x quantity and the y quantity, are changing in proportion to each other. As x goes up, y goes up a proportional amount. And then as x goes up again, y goes up a proportional amount again. And so they're changing together, almost like in unison. And so with each new point we graph, if we go a little bit over to the left on x, we go up that same amount on y. And so essentially the straight line is a visual representation of the fact that the ratios between each coordinate point, the x value and the y value, is equivalent. So for example, this is the point 1, 1. This is the point, well, I guess it's not 1, 1. It's a little bit under the line. So actually it would be really hard to use this as an example, but I think you can kind of visualize that, right? All right, then the second point is the fact that when I say the second point, I mean the second characteristic of proportional graphs is that they must contain this point 0, 0. And that one's a lot easier and simple to explain. It's because if you have 0 for your x value, and then you multiply by your k, whatever number that is, it doesn't matter, but you have your constant of proportionality, well, that's supposed to equal your y value, but 0 times any number is always going to equal 0. And so that means you kind of have to graph the point 0, 0. So that thing's a lot easier to understand than this idea of a straight line. You kind of just graph points on a proportional relationship a bunch of times, and you'll kind of like start to get a feel for why the line always has to be straight. So with all that being said, this one is a straight line and contains the origin, so I'll check it. This one is not straight, so I would not check it. This one doesn't contain the origin, so I would not check it. This one here, it's kind of hard to say. I don't know if they want us to check this one or not. Like, it's pretty straight, and it kind of looks like, depending on how you drew the line, maybe it would connect with the origin, maybe not. Just by judging looking at this paper, I think it's not. But you should check on Desmos. If you're doing it on Desmos, like click yes, click no. It should kind of tell you which one's right. If you get to the end of the assignment and it says it's incorrect, maybe just go back and fix it. It kind of looks too low to me. It kind of looks like, I don't know. It's like 50-50 whether or not they meant for this to be proportional. It just all depends on whether or not this line's really touching the origin. So I don't know. Yes, no, maybe. All right, let's move on. It says a lemonade recipe calls for 1/4 cup of lemon juice for every 1 cup of water. Use the table to answer the questions. Okay, so 1.1, what does x represent? Well, okay, I have I have a 1 in the x column here, and I have 1/4 in the y column. Well, if I go back to the problem, it says a lemonade recipe calls for 1/4 cup of lemon juice for every 1 cup of water. And so just based on these values, I think what this is representing here is the 1 cup of water. So x will be water. and the 1/4 cup of lemon juice. So this is going to be lemon juice over here. So to answer 1.1, I'd say the X represents cups of water. And then by default, I suppose that means the Y is going to represent cups of lemon juice. And so now they want to know, is the relationship between X and Y proportional? Well, you have a couple ways that you can handle this now. You should know how to check whether or not something is proportional through the table by seeing if there's this like multiplication relationship where you can always multiply the X value by the same number and get Y. Or you can check for a ratio relationship through division, right? And do Y divided by X for every single pair of values and see if those ratios turn out the same. And if they do, then it's proportional. You also have another way now. We know that if we graph the points in a proportional relationship, it must form a straight line that passes through the origin. So another way you could see whether or not this is proportional would be to graph each one of these XY pairs as coordinate points and see if they make a nice straight line, which I'm pretty sure they will. So let's see here. I have 1 for X and 1/4 for Y. So that's the point 1, 1/4. And I knew that 1/4 was right here because it's like right between 0 and 0.5, right? And I'm thinking about 1/4 being 0.25. All right, so the next one is 2, 1/2. So I'll go 2, 0.5. I don't like the fact that they give you fractions in the column in the table here and then decimals on their axis here. Like, I don't know, can we get one or the other? Whatever. All right, 3, 3/4. So I'll go to 3, and then 3/4 would be right between 0.5 and 1. The next one is 4, 1. So I'm right here in the table now. I've just been reading them down one by one. So 4, 1 is there. The next one is 5, 1 and 1/4. So 5, and then 1 and 1/4. Okay, and then 6 is, or sorry, the last one is 6, and 6, 1.5. In case you're wondering why I always make it a point to say comma when I'm graphing a coordinate point, is because it's a verbal way of expressing the split between the two numbers that make the coordinate pair. Like for example, if I wanted to graph the point 30, 1, meaning like 30 over on the x-axis, and then 1 on the y-axis. If I didn't say that comma, I would just say 31. And then you'd be like, what? The number 31? Like, what's the other point? I'd be like, no, 31. 31 what? Right? And so if I say 30, 1, you know that I'm putting the split in there. I'm gonna grab my ruler real quick. All right. I think you can tell just by looking at it that these points are going to make a nice straight line and go through the origin. But let's just put it on there anyway. So without having to do all the multiplication and division in the table, we have a visual way of confirming that this is a proportional relationship. So to answer question 1.3, I'm going to say yes, because the points form a straight line through the origin. Well, how do I know it contains the origin, right? Like, I kind of just put it there. Well, there's a couple things you could say about that. I mean, if you lined up all the points and then like draw a line through them, it kind of looks pretty clear that it's going to go through 0, 0. But also there's like a more contextual, like common sense way of thinking about it. The question is about cups of water and cups of orange juice. And well, if I'm making, or not orange juice, lemon juice. If I'm making lemonade with 0 cups of water, then it makes sense that I would use 0 lemon juice, right? Like 0 of both. So that's the point 0, 0. All right, lastly, well, for this page anyway, there's more, it says, Arturo earns $33 for babysitting 4 hours. Okay, so those are probably going to be important values. $33, 4 hours. At this rate, how much will he earn if he babysits for 7 hours? Okay, so, well, there's lots of different ways you could approach this question. You could make a table of values and start trying to figure things out. I think my strategy for this particular one, just to look at doing it this way, is I want to find the unit rate. The unit rate is, in this case, is sort of like a mathematician's way of saying, how much is he making per hour, right? That's how we talk about money that we make in real life, right? Well, some people say they have a salary and they say, oh, I make $80,000 a year or whatever. And other people have hourly wages and they say, oh, well, I make $22 an hour or whatever. And so that's what we're going to try to find out is like, how much money is this person making per hour? And when you say per hour, you're really saying per 1 hour. And so in this case, 1 hour is the unit. And that's what I mean here when I say unit rate. I want to know the rate for 1 unit, which is 1 hour. All right, so the way we do that is through division, right? We know that he makes 33 per 4 hours. And a little trick in math is sometimes to just recognize that the word per sort of like means divided by. Like when I see per, I think, oh, well, if I just do this divided by this, I'll break it down to a unit rate, right? So I want to do 33 divided by 4. That's going to tell me how much he's making in every 1 hour, also known as the unit rate. Okay, I don't have a calculator around me. I can do this one in my head. I know that 4 times 8 is 32. And so that leaves me with $1 left over because I'm trying to divide into 33. So I just have a fourth left over, right? That last extra dollar broken into 4 pieces. When you break a dollar into 4 pieces, you get a quarter, right? Literally the coin, a quarter. So I think our answer to this one's going to be $8.25 per hour. Those are like dollars per hour. So now I know how much he makes in every 1 hour. And I can use that information to figure out how much he makes in 7 hours by just multiplying by 7. So I'm going to finish this question off by doing $7 times $8.25 per hour. Oop, not $7. I'm not multiplying by $7. I'm multiplying by 7 hours. Dollars per hour. And so let's see here. 7 times 8 is 56. And then 7 times 25 cents, right? The 0.25 is 25 cents in this case. So you just think about like, what do you have when you have 7 quarters? You'd have a whole dollar and then 3 quarters more. So that's $1.75. If I add that to the 56 I got when I did 7 times 8, 57.75. All right, let's move on to the, I guess I should put a dollar sign on there. All right, let's move on to the next part. I gotta flip the page. Let me adjust this real quick. Oh. There we go. All right, so next we're given like 4 different ways of looking at relationships, like words, equations, tables, graphs, and we need to identify which ones are proportional. And right off the bat, I see a graph that does not contain the origin. To me, that's the quickest visual, easy way to see that that is not a proportional relationship. All right, next, the next easiest one to see, in my opinion, is this equation. This equation is of the form y equals kx. What do I mean by it is of the form? I just mean that it looks like this, right? It looks like y equals kx, except for where there's a k, there's a 3. Well, all proportional relationships are supposed to essentially look like this. We call this the general form of a proportional equation. I'm shortening equation as EQ. And so anytime you come to an equation that essentially looks like this, it doesn't matter what letters there are, then you know it must be a proportional equation. I'm seeing letter equals number times letter. Or in other words, one quantity always equals the constant of proportionality times the other quantity. That's exactly what proportional relationships are, like at their heart. And so when I see an equation like that, I know it's a proportional relationship. All right, so let's look at the last two. This one, in my opinion, is the hardest one to kind of understand what they're saying. The length and width of scaled copies of a rectangle. So let me draw two scaled copies of a rectangle real quick. I've got, let's say this rectangle is like 2 and 6, and then I decide to, make one that's like 2 times bigger. And so it's like 4 and 12. And so it says, we're talking about the relationship between the length and the width of these two scaled copies. So they mean the relationship between this 6 and 2 and the relationship between this 12 and 4. Well, what if we made a table with those values, right? So I'm essentially taking this question and turning it into this one just because I feel like my brain handles that better. So let's see here. These will be my width values, and these will be my length values. That's a cursive L there. And I've got 2 and 6, and then 4 and 12. And if I check the ratios between them, right, by just doing L divided by W for each one of these, 6 divided by 2 is 3, and 12 divided by 4 is also 3. So I think there is a proportional relationship there, and that should always be the case with any two rectangles. If you make squared copies of them, the ratios between their side lengths, their length and their width or whatever, those ratios have to maintain equivalency. That's sort of what makes them scaled copies. If those ratios get out of whack, then one rectangle is going to look skinnier or taller than the other, and then you don't have scaled copies anymore. Scaled copies essentially are proportional relationships. So yes, boom. All right, the last one. Oh, you know what? I didn't even notice something until just now. This one's really, really easy to see that it's not proportional either. I don't need to look at anything other than those two top numbers right there. Because I know that in a proportional relationship, whatever X value I have, if I multiply that by my constant of proportionality, which I'll just put a K there to represent a number, it's supposed to equal the Y value. But there's no K number that I could do 0 times that number equals 1. That's impossible. And so relationships can only be proportional if they have a 0 for X and a 0 for Y. So I'm not selecting that one. All right, let's do the explore part real quick. So they want us, it's similar to some of these other explore ones that we've done recently, where they want you to fill in the boxes using 0 through 9, no repeating, and you got to kind of come up with stuff on your own. And so we need to come up with two like coordinate pairs here or ordered pairs that would create proportional relationships if we graph them, right? Essentially, if we graph them, they need to be in a straight line with the origin. So what if I were to do 2, 4 and 3, 6? So I'm pretty sure those are going to be proportional to each other because in both cases, the X number times 2 would equal the Y number. But if I put them on the graph, let's see here, 2, 4 is there, and 3, 6 is there. And I think you can see that if I were to graph those, they look like they're in a straight line and through the origin. And now I have to do one where I come up with 3 points using the digits 0 through 9 without repeating. I'm allowed to reuse the digits that I used here in problem 1 now. Well, I think an easy way to do this would just be to go 2, 4 again, 3, 6 again, and then look at my line. It looks like, well, I mean, my line's not perfect. It's a little bit off of it or whatever, but 4, 8 is supposed to also be on here. Oh, wait, I can't do that. I already used 4. Okay. I can't do 1, 2 because I already used that. Ooh, I might have to think about this for a second. What to do? Well, okay. Oh, I just like drew on my wall on accident. All right. So back to the drawing board. No big deal. What if I made it 1, 2 instead, and then 3, 6, and then I can use 4, 8, right? Yeah, now I can. So it's still the same idea, but now I'm using this point 1, 2, and I'm using this point 4, 8. All right, that wasn't too bad. Now the last one, we got to do it again, and this time we have to throw a fraction in there. So let's see here. How can we make it so that this is relatively easy? Oh, I think I see one. So I'm thinking about improper fractions, right? And I'm thinking, what if I make this? Okay, so this number can't be 1. I was thinking easy right off the bat. Oh, I'll make this easy. I'll make the first number 1, but you can't make the first one number 1 because then your fraction would have to have the same number. No, I guess it doesn't. No, maybe I can make this 1. All right, what if I make this 1, and then I make this 4 over 2? So that's equal to 2, right? 4 over 2 is equal to 2. And so I pretty much just made this point again, 1, 2. I just wrote it differently. And so now I know that this point is proportional to the other 2 that I already made up here, and I haven't used 3 and 6 yet. So I can just use 3 and 6 again. These explore ones are always a little tricky. Even us math teachers, we make mistakes and get tripped up on them. So if you have a hard time with these explore ones, definitely don't feel bad. They're designed to make you have to think a little bit. All right, see you in class.